I myself, Gautam Madan, from Electronics and Communication branch. I am group leader of team number 15. The title of our capstone project is Smart IoT Health Box, and we are under the mentorship of Dr. Anil Singh sir and Dr. Ankit sir. The now rest of the members would introduce themselves.
Myself, Agrawal from Electronics and Communication branch.
Myself, Muskaan Singla from Electronics and Communication branch.
Myself, Pranav Ahlawat from Electronics and Communication branch.
I am Rohan Kumar from Electronics and Computer branch.
The outbreak of COVID-19 pandemic led to chaos worldwide because it was not only difficult for people to step out their houses as the risk of getting infected were high. Along with that, it also became difficult for people to monitor the vitals because poor people couldn't afford machines that were quite expensive. And along with that, the people staying in the NGO or the old age people at home couldn't measure the vitals because it always needed someone's assistance as well as another person to help them to measure them. So we came up with a solution to build a smart health IoT kit, which will be cost effective as well as help the oldest people to monitor their four vital parameters, that is blood pressure, temperature, and pulse rate.
So we have designed the device which includes a heartbeat sensor and a temperature sensor. The sensors are integrated with Arduino Uno, in which our machine learning model is used to find out chronic diseases, and an Arduino code is also processed through it. Arduino Uno works as an analog to digital converter, and when the patient places his or her finger on the sensors, it processes the code to display the output on 16x2 LCD display. The machine learning model uses the output values to find out if the patient is suffering from a chronic disease. And after obtaining the results, patient can consult with that doctor right at home.
Now, for the temperature measurement, we use DS18B20 temperature sensor probe. It provides 9 to 12 bit temperature readings which indicate the temperature of the device. Information is sent to or from the probe over a one wire interface, so that only one wire and ground needs to be connected from a central microprocessor to the probe. Power for reading, writing, and performing temperature conversions can be derived from the data line itself with no need of an external power source. Because each DS18B20 contains a unique silicon serial number, multiple probes can exist on the same one wire bus. This allows for placing temperature sensors in many different places.
The other vital parameter which we will measure is heartbeat. Heartbeat will be measured by a sensor named XD58C having high precision in collecting the data. As we know, heart can produce current electrical signals at a very low amplitude of sensory sensations which can easily be collected by this sensor. To get the heart rate of a human body, one needs to place his or her finger between the two sensors. The inbuilt IR sensor sends a bright signal through the blood, and the variation is detected by the IR photodetector diode. After filtering, amplifying, and sampling, the pulse amplitude modulated signal is given to the microcontroller that converts it into a suitable digital signal using a processing algorithm and produces an ECG format according to the advanced software, and sends this signal to display the system connected to it by its output port.
So moving on with the demonstration part, here we have used Arduino Uno. As you can see on the screen, we have written the codes for Arduino Uno, like the how the sensor will work if we are using Arduino Uno with it. So the codes for the temperature sensor, along with that the heart rate and the blood pressure, we have written on the you can see on the screen, and we have written the codes in Arduino Uno. And further, if we execute our codes, you can see like if you bring your finger near the sensor touch, then you'll get to see the reading on the screen for your heart rate. And similarly for the blood pressure, we have connected a LCD display which will show you the readings of your blood pressure as well as for your temperature.
Okay, So we have also designed a machine learning model for the prediction of our cardiovascular disease, and for this we have taken several parameters into account, like the age, gender, height, weight, high, low blood pressure, cholesterol, glucose, and the data set contains about 70,000 rows, which is pretty good for considering the size of the model and the complexity of the model. Also, we have plotted several graphs to show the get the general idea about a data set, and have done the pre-processing by removing the outliers and getting off some random values that were not good. After that, we have done several plotting and data set shuffling, and used the PyCaret library in Python for getting the best prediction for the model. Prediction in form of classification only, like we achieved a classification accuracy of 72% in logistic regression, and after many classifiers, the PyCaret itself gives accuracy. PyCaret itself gives the accuracy. The best accuracies were achieved in gradient boosting classifier, like gradient boosting range, LDA, random forest, and logistic regression. They all gave a competitive accuracy of about 72 to 73%, and then we fine-tuned them by selecting different hyperparameters, and got a final accuracy of about 73% on stack method for gradient boosting, light boosting, and risk like we combined all the gradient boosting, light gradient boosting, and risk classification to achieve a overall accuracy of about 72.8%. And we have finally used this model in a prediction and classification for the classification. Thank you.